Newton's second law of motion states the acceleration of an object depends on the mass of the object and the amount of force exerted on the object. It can be represented by the formula F equals m times a. So in very simple terms, if we apply the same force to objects with different mass, we have a small mass object and a large mass object. The small mass object is going to have a greater acceleration than the large mass. It's going to take us back to the first law, because remember, mass and inertia are related. So this large mass object is going to have greater inertia or greater resistance to change in motion. So it does not want to change what it's doing, so it's going to have a smaller acceleration. Now we can change an object's acceleration by changing two things. You can either change the mass or the force. So if we want this car to accelerate at a greater rate, we could either decrease the mass. So if I decrease the mass by taking some of these boxes out, the truck would have greater acceleration. I could also increase the force. If I increase the force, then the truck would have greater acceleration. Imagine putting a second person to help you push. So either one of these will cause an increase in the rate of acceleration. So you really just need to think about it with common sense. If you have three objects, look at their mass. The object with the lowest mass is going to have the greatest acceleration, assuming you apply the same force. Now, if I wanted this object to accelerate at a greater rate, I would need to increase the amount of force. We also can do calculations to solve for the amount of force that's needed. So for looking at the amount of force, what we're looking at is a relationship between mass and acceleration. So remember, when we look at the triangle, you cover what you're solving for. What you're left with is the formula. So if I'm solving for force, I'm left with m times a, because they're side by side. If I'm solving for mass, I'm left with force divided by acceleration. If I'm solving for acceleration, I'm left with force divided by mass. Now you notice the units. For these, there's only one unit for each. The unit for force is always newtons, capital N. The unit for mass in this calculation is going to be kilograms. And we've already said there's only one unit for acceleration, meters per second, or meters per second squared. So make sure you're using the correct formula when you are asked to solve.